Hi, today we're looking at Functional Skills Maths Level 2. This is the Pearson Edexcel past paper 10, and we're going to start with the non-calculator section. Question 1. Write 50 as a fraction of 125. Give your answer in its simplest form. Okay, so as a fraction, we're going to have 50 as a fraction of 125. Okay, so now we're going to say, right, I want to get it in its simplest form. So we're looking for common factors. So that's numbers that go into both 50 and 125 without any remainder. Well, I know that if a number ends in a 0, well, that means it's divisible by 10, which means it's also divisible by 5. And we've got this number is ending in a 5, so that must be divisible by 5 as well. So let's divide both of them, so the top and the bottom, by 5. So let's start off with the 50 divided by 5. We'll do it with the bus stop method. Well, 5 goes into 5 once, and 5 into 0 goes 0 times because it can't. Okay, so we've got 50 divided by 5 is 10. We'll do the same with the 125. So we put it in the bus stop, and we put the 5 on the outside. Okay, does 5 go into 1? No, it doesn't, because 5 is bigger than 1. So we say, what about 5 into 12? Well, we've got 5, 10, 15. That'd be too many, so we'll just go with twice. 2 5s are 10. And then, well, we've got 12 this, we've got 11, 12, so that's 2 left over, or remainder 2. We write the remainder in before the 5. So now we've got 25. So how many times does 5 go into 25? We've got 5, 10, 15, 20, 25. That's 5 times. Okay, so this is simplified. 50 divided by 5 is 10. And 125 divided by 5 is 25. Okay, but we can't just stop there because this can actually go smaller. So we're looking at it and we say, well, what can we divide these by? Well, again, it's ending in a 0, which means we can divide it by 10 and 5. And this number's still ending in a 5, so we can divide top and bottom by 5 again. Now, instead of using the bus stop method, I'm just going to say, well, 10 divided by 5, well, we've got 5, 10, that's twice. And 25 divided by 5, 5, 10, 15, 20, 25, that's 5 times. So 50 divided by 125 in its simplest form is 2/5. B. Work out 18.17 plus 4.398. Right, so let's write these one on top of the other, and we're lining up the units. So we line up the tenths and the hundredths and the thousandths. We've got nothing there, so what I'm going to do is I'm going to put a 0 there. So I've got something to add it to, just like a placeholder. So 0 plus 8 is 8. 7 plus 9, that's 16. 6 carry 1. 1 plus 3 is 4, plus 1 is 5. Bring down the decimal point. 8 plus 4 is 12. So put the 2, carry the 1. And 1 plus 1 is 2. So we've got an answer of 22.568. Question 4. Question 2. Work out 5 3/4 minus 2 5/8. Right, okay, well, we've got two things going on here because we've got a mixed number. So we can't really just deal with the fractions and the whole numbers separately. What I'm going to do is I'm going to turn both of these into improper fractions. So we want to get rid of the whole number part. So let's start off with the 5 3/4. 5 3/4. Okay, so by improper fraction, I mean, instead of having a whole number, we'll just have a number of fourths or quarters. And the way we do that is we multiply the whole number by the denominator. So we're going to have 5 times 4. And then we just add on whatever the numerator is. And all of that is going to be over the existing denominator. So you'll see if we do 5 times 4, we've got 4, 8, 12, 16, 20, and then add 3, we've just got 23. And that's all over 4. Now, if you just want a bit more explanation of what we're doing there, the reason we're multiplying the 5 by the 4 is because we're saying 5 whole numbers is like 4 quarters, plus another 4 quarters, plus another 4 quarters, plus another 4 quarters, plus the 5th 4 quarters, so like 1, 2, 3, 4, 5, and then we've got 3 quarters. So I'll just do that on the side there. So this is all adding up to this, okay? So this is just to help you. Don't need to do this one. Right, now we want to get 2 5/8 as an improper fraction, okay? And we're going to do the same sort of thing. So we multiply the whole number by the denominator. So we'll have 2 times 8. Then we'll add on the numerator, the number on top. And all of that is going to be over the existing denominator. So we've got 2 times 8, well, that's 16, plus 5 is 21. And all of that is over 8. So this thing up here, what should we do? We can put 5 3/4 minus 2 5/8 is the same as 23 quarters minus 21/8. Right, now this helped, but we still can't do our subtraction just yet because our denominators are different. Okay. So what we're going to do is get them the same. So we say, well, does one of the denominators go into the other? Well, yeah, 4 goes into 8. And how many times does 4 go into 8? Well, 4 goes into 8 twice. Okay, because 4, 8. There you go. So we want to rewrite this fraction as having a denominator of 8. And if we said that, well, to get from the 4 to 8, we're doubling it or multiplying by 2, well, we need to do the same to the numerator. So we're going to multiply that 23 by 2. So 2 times 3 is 6, and 2 times 2 is 4. So we're saying that 23 over 4 is equivalent or equal to 46 over 8. And this one we can keep exactly as it is because it's already over 8. So our denominator is the same. So when we get this situation, that's great. We know if we're dealing with eighths, our answer is going to be eighths. So all we need to do is 46 minus 21. So I'll do that over here. So 6 minus 1 is 5. 4 minus 2 is 2. So we've got 25 divided by 8. But we're still not quite finished because they've said give your answer as a mixed number. So we don't want it as an improper fraction anymore. We've got to turn it back into a whole number and a fraction. So what we're going to do is say, well, 25 divided by 8. How many times does 8 go into 25? Well, we've got 8, 16, 24. So that's 3 times. And, well, if that's 24, we need one more eighth. Oh, what have I done? To get up to 25. So again, what we were doing before, the 3 and 1/8 is saying like we've got 3 lots of 8/8. So 8, 16.24, and then we've got the 1 more eighth to make it 25/8. Question 3. Hannah wants to buy a new washing machine. She will use one of these offers. So offer A, we've got 24 monthly payments of £30. Offer B, normal price £954, now 22% off. Hannah wants to spend the least amount of money. Which offer should Hannah use? Show why you think this. Okay, right, let's start with offer A. So 24 payments of £30, so we can just do 24 times, and I'm just going to multiply it by 3. I'll ignore the 0, and we can put it back on afterwards. So 3 times 4, we've got 4, 8, 12. 2 carry the 1. And 3 times 2, or 2 times 3 is 6, plus 1 is 7. Then we put the 0 on there, so we put the 0 on here. So we've got a price of £720. Now we've got offer B. Okay, so we've got £954 and there's 22% off. So what we can do is work out what 22% is and then subtract it from 954. Well, if you think 22 is made up of 10 and another 10, and then I'm going to split it down into a 1 and another 1. Okay, the reason I've done that is because, well, I know that if I want 10% of a number, well, if it had a 0 on the end, I'd just take the 0 off. But as it hasn't, I imagine a decimal point there and just move it over once. So 10% of 954 is going to be £95.40. And then, well, we said 1% as well. Well, 1% of 954, well, that's like dividing by 100. And with that, we again imagine a decimal point, and we're going to move it twice, because 100's got 2 zeros. So that would be £9.54. So if we want 22%, remember we said it's 10, which is £95.40, and another 10, it's another £95.40, and 1, which was £9.54, and another 1, which is £9.54. So we're going to add these all together. Let's move this up a bit. 0 plus 0 plus 4 plus 4 is 8. With these, I'm actually going to add the 5s together first, because 5 plus 5 is 10, plus 4 is 14, plus another 4 is 18. Carry the 1, bring the decimal point down. 5 plus 5 is 10, plus 9, actually I'm going to do the 9 plus 1 is another 10, plus 9 is 29. 9 plus 9 is 18, add 2 is 20. So we've got £209.88. That's the amount that's been taken off. Okay, so we need to go back to the original price, 954, and subtract the £209.88. And I'm going to put 0 pence, so we've got something to take the 88 away from. Well, at the moment, I can't take 8 away from 0. I've got nothing to borrow from over here, so we're going to take 1 from the 4, reduce that to a 3 and pass 1 over here. We can then reduce that 10 to a 9 and pass the 1 we've reduced it by to this 0. So now we've got 10 minus 8, which is 2. 9 minus 8, which is 1. Give our decimal point. 3 minus 9, well, 9 is bigger than 3, we can't do that. So we'll reduce the 5 to a 4 and make that 13. So 13 minus 9 is 4. 4 minus 0 is still 4. And 9 minus 2 is 7. So we've got, for offer B, £744 and 12p. Well, Hannah wants to spend the least amount of money. Well, 720 is less than £744.12. So offer A is cheaper. Question 4. Jack is managing a concert. The diagram shows the total floor space for the concert. So we've got this diagram here, 64 metres across, 90 metres up this side, and 100 metres up this side. Jack receives £21 for each square metre of floor space from ticket sales. He donates 1/7 of the total he receives from ticket sales to a charity. How much money does Jack donate to the charity? You must show you're working. Right. Well, if he's getting £21 for each square metre, we need to work out what the area of this is. Okay. Now, you could draw a line here and split it into a rectangle and a triangle, but you might look at this, you might even want to turn the page around and say, well, actually, when I look at it like this, it looks a bit more like a trapezium now. So I've got my set of parallel sides, it's a four-sided shape. So, turn this one back. And it might help to show the sketch like that. So, because often when we have a trapezium, we see it more like this. So that's with the 90 metres on the top, 100 metres on the bottom, and 64 metres up the side. So hopefully you'll remember the area of a trapezium. We have a nice formula for that, which is half times A plus B, where A and B are the two parallel sides, and then multiplied by the height, which is 64 here. So in other words, we want half of 90 plus 100, and then we'll multiply that by 64. Right, so we'll just do this one step at a time. We've still got the half. We'll do the brackets first, 90 plus 100. Well, that's just 190. Then we're going to multiply it by 64. So we've got a choice on which order we want to do our multiplications here. Which way shall we do it? I'm going to do half of 190 first. So if you think half times 190, well, that's the same as 190 divided by 2, which we can do with the bus stop method. So 2 doesn't go into 1, but 2 goes into 19, 2, 4, 6, 8, 10, 12, 14, 16, 18. That's 9 times, with 1 left over. And 2 goes into 10, 2, 4, 6, 8, 10. That's 5 times. Okay, so we can rewrite this. So we've done this bit is 95 times 64. Okay, I'll do this over here, 95 times 64. You could do this with the grid method. I'm going to do it with the column method. Any other way you like to do these. So I'm going to start off by saying 4 times 5. 5, 10, 15, 20. 0, carry 2. 4 times 9. 9, 18, 27, 36. Add on the 2, makes it 38. Now we're going across to the 10, so we put a 0 here in the units. So we want 6 times 5, or 5 times 6. 6, 12, 18, 24, 30. So 0 carry with a 3. And 6 times 9, 9, 18, 27, 36, 45, 54. And we add on the 3, 55, 56, 57. Then we want to add these together. So 0 plus 0 is 0, 8 plus 0 is 8, 3 plus 7 is 10, 5 plus 1 is 6. So we've got 6,080 metres squared. Okay. Now, Jack receives £21 for each metre squared. So we could do 21 multiplied by this. But remember, he donates 1/7 of the total to charity. And that's what we're trying to work out. So rather than doing the 21 times 6,080, which might feel quite big, we can say, well, he's only going to give 1/7 of that. So actually we can work out 1/7 of 21. Or in other words, 21 divided by 7. So 7, 14, 21. That's 3. So he's only going to donate £3 for each metre squared. So that means that we just have to do 3 times 6,080, which is going to make life a bit easier for us. 3 times 0 is still 0. 3 times 8, 8, 16, 24. 3 times 0 is still 0, but add the 2. And 3 times 6, 6, 12, 18. Let's put our comma in, so count back 1, 2, 3. So we've got a total of £18,240. And that's the end of the non-calculator section. And now for the calculator section. Question 1. Marta and Aki want to move into a 2-bedroom flat. Marta will have the bigger bedroom. The total monthly rent for the flat is £720. Marta and Aki will share the cost of the rent in the ratio 9 to 7. Marta thinks she'll pay less than £400 of rent. Is Marta correct? Show why you think this. Okay, so ratio question. So we'll do a little ratio table. And in my ratio table, we're going to have Marta and Aki. And I'll put a total column. And we've got the ratio of 9 to 7. Now, if that's all we had, 9 and 7, well, the total, so 9 plus 7, is 16. But actually what we have got, we've got a total monthly rent of £720. So put it in the total column. And we're trying to work out, using multiplication, how to get from this row to this row. So we want to do the opposite of multiplying, which is dividing. So we want to know what 720 divided by 16. Well, we can use our calculator. So 720 divided by 16. That gives us 45. So we're multiplying by 45. Okay, so whatever we do to the top row, we can do the same for all of the numbers. So we're going to multiply that by 45 and multiply the 7 by 45. Okay, so 9 times 45 is 405, and 7 times 45 is 315. And if we want to check, 405 plus 315 should give us the 720. So the same, Marta thinks she'll pay less than £400 a month in rent. Well, she's going to pay 405. So 405 is more than £400. So is Marta correct? No. Marta is incorrect. Question 2. Ben is the manager of a mobile phone shop. He starts to record the sales of mobile phones to 50 customers. Okay, and we've got it split here. We've got the model, so we've got either a mini, regular or maxi phone. And then we've got by storage size. So 64 gig, 128 gig, or 256 gig. So, for example, we can look at this 5 means that he sold 5 mini phones that had 64 gigabytes of storage. Okay. They say, complete the table for Ben. Well, we know that there's 50 in total, so all we've got to do is add these all up and work out what we need to make it up to 50. So I'm going to do, let's just add them all up. So 5 plus 7 plus 6 plus 2 plus 9 plus 8. So I'm adding this way, and then plus the 4 plus the 6. So we get 47. We've got 50 in total, so we want 50 minus 47, which gives us 3. So that must go in there. Then they say, Ben selects at random one of the customers who bought a mini mobile phone. Okay, he bought a mini mobile phone, so we're only interested in those. What's the probability that this customer bought a 128 gigabyte mobile phone? So because we're only interested in those, we want to know the total of these. So in other words, we want 5 plus 7 plus 6, which gives us 18. Okay, so it's going to be out of 18. And we want the ones that bought a 128 gigabyte phone. And there were 7 of them, so it's just going to be 7 out of 18. Question 3. Emma hires a large tent for a party. The diagram shows the shape of the ceiling of the tent. The ceiling is made up of a rectangle and 2 semicircles, as we've got on here. What I'm going to do actually is just draw a line down here, so we can see we've got one semicircle here, another one here, and this is our rectangle. Emma wants to put a flower garland around the edge of the ceiling. If you're not sure what a flower garland is, it doesn't matter. It says around the edge of the ceiling. So basically all we're saying is we're looking at the distance round this. She has 40 feet in length of flower garland, and we're told to use 1 metre equals 3.3 feet. Does Emma have enough flower garland to go around the edge of the ceiling? Well, that means we want to know what the distance is all the way around, but we're going to get that distance in metres. We're then going to need to convert it into feet using this conversion here, and then compare it to the 40 feet here. Okay, so, well, we know that this section is 2 metres, and that means that this is going to be 2 metres as well at the bottom. What we don't know is that distance round there, and that distance round there. Now, although they're saying that they're 2 semicircles, we can think, well, if they're 2 semicircles, if you put them together, they're going to make 1 circle. And that circle is going to have a diameter, the distance from one side to the other, going through the middle, of 2.8 metres. So we want the distance around the circle, which is the circumference. And the circumference of a circle is, well, you might know it as 2 pi r, or you might know it as pi d. Okay, we've got the diameter rather than the radius, so we're going to use this version. Well, pi is 3.14, and d, the diameter, is 2.8. And when you've got a letter next to another letter or next to a number, we need to put the multiply sign in between. Okay, so let's work out this circumference. So 3.14 times 2.8. 8.792 metres. Okay. Now, because we've stuck the 2 semicircles together, that's our answer for these 2 distances. Some people might say, well, we need to half it to get the semicircle. Well, you can half it to get the distance on one semicircle, but then because you've got 2 of them, you're going to have to double it, so you'll end up back with what you started anyway. Okay, so if we want the full distance or the perimeter, we're going to need the 8.792 for the two semicircles, and then we're going to need 2 meters for this length and another 2 meters at the bottom. So we can add 2 and add another 2. So we get 12.792 meters. So we said we need to turn the meters into feet. So if it's 3.3 feet for 1 meter, for 12.792 meters, we're going to need to multiply that by 3.3. And we get 42.2136. That's now in feet. Does Emma have enough flower garland? Well, 42.2136, which is what she needs, is more than 40 feet that she has, so no. She does not have enough. Question 4. Jake and Tia are preparing to take part in a 10-kilometre race. They both run 10 kilometres each week for 6 weeks. Jake records his times. So in week 1 he took 65 minutes, week 2 he took 59 minutes, and so on. Tia says, my median time is 61 minutes. Is Jake's median time greater than Tia's median time? Well, the median means the middle one. But it's not just picking the middle here, we've got to put them in order first of all. So we want to rank them from smallest to largest. So what's the smallest? 56 is the smallest. So then the next smallest number, 59. 58 would come next. Then 59. Then 65. Then 62 would be next. We've got 65 and 66, so it would be 65. And then 66. So then we cross off the smallest and the largest, and we keep doing that in pairs until we're left with either 1 in the middle, or in this case, we've got 2 in the middle because we had an even number of values. So that means we need to add them together and then divide by 2. So 59 plus 62, divide that by 2, and we get median equals 60.5, and that's minutes. Okay, well, 60.5 is less than 61, so no, it's not greater. You could round it. If you rounded it to the nearest minute, you'd have 61 minutes, so you could argue that they're the same, but it's still not. It's asking if it's greater than, and it's definitely not greater. So we need to give no as an answer there. Then we've got part B, show a check of your answer. Well, we can work backwards. We had a value of 60.5, so we can do 60.5. And then we divided by 2, so we can multiply that by 2. Which takes us back to 121, which is what you get from adding 59 and 62 together. I suppose what we could do is we could then take away 59 to check we get back to 62. So that would be a sort of a nice full check there. Question 5. Ms. Daly gives her students 1 week to prepare for a maths test. The scatter diagram shows the number of hours spent on revision and the mark in the test for each of 31 students. Okay, so let's pick a value. I was trying to find a nice one. Let's go for something like this. Well, so this is saying, well, if that's 5 hours, each of these must be 1 hour. Each 2 boxes, so that'd be 1, 2, 3, 4. So this is saying that if they spend 4 hours revising, they got a mark of 20. Okay? And you can do a similar thing for these other values. Okay? We're then told another student revised for 12 hours and scored 45 marks on the test. Plot this point on the scatter diagram. Okay, 12 hours. Well, we've already sort of seen from here that we need 2 of these boxes for 1 hour. So that'd be 1, 2, 3, 4. So for 12 hours, well, if that's 10, that would be 11. That's going to be 12. And they scored 45 marks. So we're going to start at 12 and we're going to go up. And 45, well, it's going to be halfway between 40 and 50. So we can put a cross in there. And then part B. What type of coloration does the scatter diagram show? Well, correlation, well, we can describe it or we can use one word. I'm going to do both. Basically, the type of correlation we're looking at is, well, as the revision time increases, so as this gets bigger, the mark increases. So this is what we would call a positive correlation. Okay. If it was a negative correlation, well, then the values will be sloping down this way instead. Okay. So we can say positive correlation, but then we can actually say what it means. So something like, as the revision time increases, so does the mark. So it's showing we actually know what it means. We can understand this graph. Okay. Then we've got a part C. Ms. Daly uses the scatter diagram to recommend how much revision time students need to get a high mark on the test. What percentage of the students who revised for more than 15 hours scored over 70 marks in the test? Okay, so, a couple of things. We need to go back to the diagram first of all. So, we want percentage of students who revised for more than 15 hours first of all. So, we can draw a line up from 15 hours. We're only interested in these over here. Okay, but then they also said, what was the question? For more than 15 hours that scored over 70 marks in the test. Well, let's draw a line at 70. Okay. Well, if we look at just these first of all, so these are the ones for the people that revised for 15 hours or more. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11. So it's going to be out of 11. We're only interested in those. And then we want the ones that scored over 70%. So that's 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 8 out of 11. Okay. Well, that's great as a fraction, but they said they want it as a percentage. So we need to multiply that by 100. Which gives us 72. And we can do it to one decimal place. So 7. 2 is less than 5, so we just keep it at 72.7%. Question 6. Alia is a baker. In April, she will use 400 kilograms of flour to make bread. In May, she plans to increase the amount of bread she makes by 14%. Alia needs to order the flour she needs to make the bread in May. How much flour does Alia need to order to make the bread in May? Lots of words there. It takes lots of time to read it out, when actually it's quite a straightforward question. What they're saying is increase 400 by 14%. So the way we can do that is work out 14% of 400, so 14 out of 100 for the percent, multiply it by 400, which gives us 56 grams, and then we just need to add it on to the original 400, which gives us 456 grams. Oh, sorry, not grams, it's kilograms, isn't it? Kilograms. In fact, they've put the units down for us, so that would help as well. Question 7. This graph can be used to convert between miles per hour and kilometres per hour. Okay, so what we can do is, it's always nice to try and pick a point like this or this. This is a nice one, but if we look at something like that, you can see it's halfway between 20 and 30, so that must be 25. So we'd be saying 25 miles per hour is the same as 40 kilometres per hour. Okay, just to give you an example. Now they've asked us to use the graph to complete the table. Right, and here's our table. So we've got 30 miles per hour. So what we do is we find 30, draw a line up, find where it meets the line, and then draw a line across. Okay, so we want to read off the kilometres per hour. Now, from 40 to 50, it's a change of 10 kilometres per hour, but we've got 1, 2, 3, 4, 5 boxes. So that means that each of these must be worth 2. So in other words, we've got 42, 44, 46. So that is going to be 48 kilometres per hour. Now they want us to do it the other way round. So kilometres per hour, we've got 64. So we need to find the kilometres per hour on here. And remember, we said each of these boxes is worth 2. So that'll be 62, 64. And then we draw a line down. This one looks nice because it's on one of those big thick lines. So it's coming out exactly at 40 miles per hour. Kareem buys a new car. The fuel tank of the car has a capacity of 62 litres. He knows 1 gallon equals 4.546 litres. What is the capacity of this fuel tank in gallons? Give your answer correct to 2 decimal places. Right. It might help to think of this a bit like a ratio or a proportion question. So if we had gallons and litres, 1 gallon is 4.546 litres. Now, we've got the capacity is 62 litres. So if we're trying to find out the number of gallons here, what we need to do really is find out what this is increasing by. And we've said the way we do that is by starting with the bigger number and dividing it by the 4.546, the smaller number. So 62 divided by 0.546 gives us 13.638363. I'll write all the digits for now. Okay, so if that's what we're multiplying that by, blah, 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 we would then multiply this by the same. Well, this is just 1 multiplied by it. So the answer is going to be 13.638, whatever. Okay, but they've asked us to give the answer correct to 2 decimal places. So these are the 2 decimal places. So we look at the digit afterwards. An 8, so that's more than 5. So we round this 3 up to a 4. So we end up with 13.64 gallons. Question 8. Amir is a builder. He needs to work out how much it will cost him to build a wall. Amir uses this information to work out the number of bricks he needs. The wall will be 7.9 metres in length, 9 bricks in height, and 8.6 metres in width. The bricks Amir will use are in the shape of a cuboid. We've got the measurements on here. Amir has these prices for bricks. He uses the mode of these prices to work out the total cost of the bricks he needs for the wall. Amir will also pay £75 for the other materials he needs to build the wall. Work out the total cost of the bricks and other materials for Amir. Right, okay. So, we've got a few things to do on this. The first thing we need to do, well, maybe not the first part of the calculation, but at some point we're going to need to multiply by the price per brick. And we're told that that price per brick, he uses the mode of these values. So I'm going to work that out first. Okay, so the mode means the value that occurs most often. Okay, so we could kind of write all of these down and see how many we've got of each. But actually, if we look at them, £1.50, £1.75, £1.68, £1.99, £1.65, £1.80, £1.49, £1.50, the only value that occurs more than once is £1.50. So that is going to be the mode. And that's what we're going to use at the end, once we know how many bricks we're going to need. Okay, right. So we want to know how many of these bricks are going to fit in this wall. Now, you could work out the volume of the brick, the total volume of the wall, and divide one by the other. Now, if it was a level 1 question, that would be fine. For level 2, you can't necessarily do that because we don't know if we're going to have complete bricks, if they're going to fit perfectly into this distance. So when you've got a level 2 question, what you want to do is think about each of the dimensions separately. Now, before we do that, we've also got the problem that these measurements are in millimetres, and at least 2 of these are in metres. So we want to get everything in the same units. So I'm going to turn my metres into millimetres. Okay, I could go the other way around, but then I'm going to have lots of decimal places. So if I want to turn this into into millimetres, I know that there are 100 centimetres in 1 metre, and also that there are 10 millimetres in 1 centimetre. Okay, so that means we need to multiply the 7.9 times 100 to turn it into centimetres, and then times it by 10 to turn it into millimetres. Okay, but I don't want to write millimetres there until I've worked out the number. Okay, so 7.9 times 100 times 10 means we've got 7,900 millimetres. So if we do the same for the width, we're going to want 8.6 times 100 to turn it into centimetres. God, I'm making lots of mistakes here. And then multiply it by 10 to turn it into millimetres. So 8.6 times 100 times 10 is 8,600 millimetres. Okay, so you could try and work out the total volume, so that would work on level 1. But also, if you look, if we're going to be multiplying numbers like this together, we're going to be getting something really huge and quite difficult to deal with. So instead, we're going to say, well, I'm going to draw a quick picture, actually, of what our wall is going to look like. It's going to be 7.9 metres this way. It's going to be 8.6 metres this way. And then it's going to be 9 bricks high. So if you imagine we've got like 1 layer, 2 layers, and so on. Okay, so that might just help to visualise this. So what we're doing is we're just going to look at this distance first of all, and imagine that we're putting our bricks in. How can I draw this 3D? Like that. Okay, we're going to have 1 brick there, and we're going to have other bricks. So how many bricks can we put along lengthways? Well, we want the 7.9 metres, which we worked out as 7,900. We want to divide that by 215 to see how many of these bricks we can fit in there. So 7,900 divided by 215, and we get 36.744 bricks. Well, you can't have 0.744 of a brick, so we're going to round it up to 37 bricks. Okay, and we might have to just chop a bit off the brick. So now we're going to look at this dimension, the 65 millimeters. So how many 65s are going to fit into the 8.6 meters? So 8,600. Divide it by 65. And we get 132.3. Again, we can't have 0.3 of a brick, so we're going to have to go up to the nearest whole brick, which would be 133 bricks. So the total number of bricks that we need are going to be 37 bricks in this direction times 133 bricks in that direction, and then times, remember, it's 9 bricks in height, so we're going to multiply that by 9. So 37 times 133 times 9 gives me 44,289 bricks. Okay, so if we want to work out the cost, we want 44,289 times £1.50. Because remember, we worked that out as the mode. So 44,289 times £1.50 gives us £66,433.50. Now, the last bit, and it'd be very easy to miss this out, Amir will also pay £75 for the other materials. So probably the easiest bit of the question, but I can imagine lots of people just forgetting or missing this bit off. We just need to add 75 on. Okay, so that's why it's really important to read the question carefully, because say this is, anyone can type plus 75 in their calculator, but it would also be very easy to miss that off. And this is our total price for all of the bricks plus the other materials. Question 9. Craig works on a building site. You know it takes 2 bricklayers 3 hours to lay a total of 450 bricks. On Monday, there are 5 bricklayers at the building site. All the bricklayers work at the same rate. How much time would it take 5 bricklayers to lay a total of 450 bricks? Give your answer in hours. With something like this, it really helps to just think kind of practically. We had 2 bricklayers taking 3 hours. If we've got 5 bricklayers, do we expect this time to increase or decrease? Well, if you've got more people, you'd hope it's going to be done quicker. So if we get an answer that's bigger than 3, we know we've done something wrong. So let's think about how many hours of work are spent altogether. Well, 2 bricklayers working for 3 hours each. 2 times 3, we've got 6 hours of work. If we've got 5 bricklayers, well, we can divide that 6 by 5, which gives us 1.2 hours of work each. And that's our answer. Question 10. Work out the value of 13.608 divided by 3.24 all squared. And you'll notice I read it as this divided by that because this is in brackets. So we do the squaring afterwards. Okay, so we've got the calculator. 13.608 divided by 3.24. So it's 4.2 and then it's squared. So that just means 4.2 times 4.2 squared, just multiplied by itself, which is 17.64. You can write that here. Write 3/8 as a decimal. Again, we've got a calculator. 3/8 just means 3 divided by 8. 0.375. Question 11. Ben is the manager of a leisure centre. He has this formula to work out the volume of the water in the pool. And we've got the V equals 10 dW plus 15 AW, where V equals the volume of the water in the pool in metres cubed, D equals the depth of the water at the deep end of the pool in metres, W equals the width of the pool in metres, and A equals the depth of the water at the shallow end of the pool. Okay. Ben knows the width of the pool is 12 metres, the depth of the water at the deep end is 2 metres, the depth of the water at the shallow end is 1.5 metres. Ben uses 2 water pumps at the same time to empty the pool. Pump A empties water at a rate of 31.2 metres cubed per hour. Pump B empties water at a rate of 27 metres cubed per hour. Ben thinks that using the 2 water pumps will empty the pool in less than 9 hours. Is he correct? Okay, well, let's start off by working out how much water we've got to empty. So we've got this formula here, and we can just put all our values in it. So V equals, 10 is still just 10. When a number's next to a letter, it means multiply, and D is the depth of the water at the deep end. Well, that was 2 metres, so it's just times 2. Then there's another letter, so when they're next to each other, we need to put a multiply in there, times. W is the width of the pool. The width of the pool is 12 metres. Okay, so we've got that. Then we've got plus 15, stays as it is, next to a letter, so we're going to multiply, and instead of A, we're going to substitute the depth of the water at the shallow end. The depth of the water at the shallow end is 1.5. And then we're going to multiply it by the width again, which was 12 metres. Okay, now if you remember with the order of operations, we do multiply before add. So we're going to work this out, and then add them together. So 10 times 2 times 12 gives us 240, and 15 times 1.5 times 12 gives us 270. So the total volume is going to be 510, and what did I say the units were? Metres cubed. Right, great. Now we've got to work out the time to empty the water out of the pool. Well, we've got 2 pumps working together. Well, if one's doing 31.2 metres per hour and the other one's doing 27 metres cubed per hour, well, if we're doing both of them at the same time, we can just add those 2 together. So in total, they're going to be emptying 58.2 metres cubed of water per hour. So if that's per hour, we want to know, is that going to be enough? So it says in less than 9 hours. So what I'm going to do is I'm going to do the 510, divide it by 58.2, because we're saying we're taking that much out of the pool every hour. So if I do 510 divided by 58.2, this should tell me how many hours it's going to take to empty that pool. And we get I'll do it to 2 decimal places, 8.76. It's less than 5, so we just keep those 2 decimal places there. And that's 8.76 hours. Well, 8.76 is less than 9. And remember, it's 8.76 hours. It's not 8 hours, 76 minutes or anything like that. 8.76 hours, so it is less than 9. So, yes, he is correct. You can do it in less than 9 hours. Okay, question 12. Ricardo gets a new job at a leisure centre. He records the number of visits of 50 clients in August. So there were 8 people who made between 1 and 7 visits, 25 visitors that made between 8 and 14 visits, 12 that made between 15 and 21 visits, and 6 people that made between 22 and 28 visits. And there were 50, as it says, 50 clients in total. Ricardo works out an estimate for the mean number of visits by these clients in August. His manager tells him this is a 16% increase on the mean number of client visits in July. What was the mean number of client visits in July? Right, so we're going to have to work out what the mean is of these values and then work backwards to see what it would have been in July. Right, well, we've got ranges here, 1 to 7, 8 to 14. So we need to know the midpoint because we don't know exactly how many visits these people made. So we're going to assume that it was halfway between all of these values. So what we can do for that is if it's halfway between 1 and 7, we do 1 plus 7 and divide it by 2. So 4 would be halfway. And we'll do it the same for all of them. 8 plus 14 divided by 2. So the midpoint's 11. And then 15 and 21 divided by 2 is 18. 22 plus 28 divided by 2 is 25. So we can ignore these now because we're using the midpoints instead. So if you remember with the mean is the total divided by the frequency. Okay. Well, to work out our total, we can't just add these up because there were 8 people that made 4 visits. So we're going to need to multiply these together to find out how many people there were. So if 8 people made 4 visits, 8 times 4 means that there were, so we can put, there were 32 visits for this range. Okay, 24 times 11. So we're saying 24 people that made 11 visits. That's 264 visits in total. 12 times 18 is 216. 6 times 25 is 150. So if we do a total of all of this, we get all of the visits made by all of the people. So 662, and we know that there were 50 clients in total. So 662 divided by 50 means that on average, or the mean, there were 13.24 visits per client. His manager tells him this is a 16% increase on the mean number of client visits in July. So what we're saying is 13.24 represents, if it's a 16% increase, that means it represents 116% of the original value. So if we want to find out what it was before that increase, well, let's think about what 1% would be. So we want to do 13.24 divided by 116% to find out what 1% is. And then, because we want to find out what it was, we want to find out what the original 100% was, we're then going to multiply it by 100. So 13.24 divided by 116, multiply it by 100, and we get 11.41 to 2 decimal places. Okay, and finally, we've got a part B to question 12. Use a reverse calculation to show a check of your estimated mean. Well, we're just going to work backwards. So we had an answer of 11.41. We multiplied it by 100. So we're going to divide that by 100 and then multiply it by the 116. And that should take us back to 2356. Yeah, I'll write it all out. which is approximately equal to 13.24, which is what we started with. So that's the end of the paper. There's a couple of tricky questions there. I'd say question 12 and especially question 8 really got to be careful with that brick question because you can go off on a bit of a tangent. So I hope you found these suggested answers helpful. Remember, there is more than one way to answer a lot of these questions. Please like the video, subscribe to the channel, have your notifications on to find out when I load more videos, and I look forward to seeing you again soon. Thank you.